You're welcome to today's class. We are still on storage classes. Today we are going to look at the last storage class, which is what? The extern storage class. And then I told you this is like the religion, the science, the philosophy. So you are looking at that highest layer that the laws and the instruction will cascade down to the auto. So this one will tell you which part of the memory, which is still what the data segment, you are going to store the values. Now, I'm going to write two programs to explain the external storage class. So the first one, so today we are looking at external storage class, all right? And then we are still using this blueprint, which is what? The location, memory location will be what? In the data segment. Data segment. Then the scope, in this case, is global. So when we say the force of gravity, what is it? Is universal to everybody. Then we say lifetime throughout the program. So even when the function returns, it will still exist. Then the default value, if it is not initialized, is what? 0. So that is what you are looking at. So I'm going to write two programs to illustrate this. So the first program will contain the main function. So there I will say include stdio.h, and then I'll use the extern keyword. Extern, I'll create the variable shared value, right? I'm declaring the variable, so I have to put the data type. So extern int shared value, right? Then I'm also going to create a function. Now, I can use the extern keyword for the function, but it's optional. In C, when you declare a function without stating the storage class, automatically going to take extern, so no need to use it. So I'll just say void, and I'll say extern example. So this is a declaration, meaning the definition will be in another file. Then I'll say int main. I'm calling my main function. Inside this main function, I'm going to call this extern example. And then I'll call it again. And then I'll say return 0. So I'll close my main. So this is one file that I've created. I'm going to save this as maybe main.c. I'll just save it this way. Then I will come here and I will create another program that will carry the definition of this function, and then the assigned value to this shared value. So here I will say include stdio.h, and in this place now I am going to give the definition of this shared value without the extern keyword. So I will say int shared value, and I will assign 5 to it. Then the function definition, void extern example. Inside this, I'm going to increment this my shared value. So I'll say shared value plus plus. So I'm increasing the value inside this function. Then inside the function, I will say print f shared value equals to what should be there is what I want to write here. Percentage D slash N, then we'll close the bracket, comma. What should be here? I don't know if you are still seeing. I'll write it shared value, right? So that's my program. Then I'm going to close this. So that is my program. I'm going to compile this, or I'm going to save this one as maybe extern underscore demo dot c. So that's how I'm going to save it. So this one file, this is another file. Then in my code block, I'm going to combine these two files together as a project and then run it. So when I run it, it will come to this place, main. So what it has done is it will look at this external variable. So it's the global variable. It will create a location in the memory, in the data segment, right? And assign this value to it, which is what? 5. And then in this main, you are calling the external example. Control will go to this guy. That is why you have to compile them together. Otherwise, it will not see it. It will not locate this. If you don't compile it inside the same project, it will not see it. So it will come here. When it accesses this external example, it will come in and it will increment this shared value to what? To 6 in the memory location where it has created the data segment. It will increment it to 6, and then it will print out shared value out. It will be what? It will print out shared value equals to what? 6. Because it did this increment before printing out the value. So it will become what? 6. Then it will return to this guy, to this main. But when it encounters this and return to main, this shared value will still remain in data segment with this current value as 6. Then when you call it again here the second time, it will come back here again. It will go in and it will access this in the data segment with the current value as 6. It will increment it to what? 7. Then to print it out, shared value equals to what? 7. So it's the printer shared value equals to 6 and shared value what? Equals to what? 7. Just like the static memory. But this time around, it is global. Static memory can be both local within the function or global. But in the extern, it is what? Always global, meaning everybody can access that variable. So that is what I want to show you in the class of storage classes, right? So let's go to code blocks. Let me show you how to combine these two programs together and execute for it to show you the output. If there is any uh, issue with any of these storage classes at their alignment layers, then you will have a corrupted output. So that is what I want to show you. And this concept can be used to run a society, right? So don't just blame the presidency. The religious leaders have a say in how a society is being run. So if the presidency is corrupt, coming from the static memory, which is the family, also coming from the extern, which is the religion or science or philosophy, then they also have a major play in the society. So you can also see that the corruption might not just come from the presidency, but it might also come from the religious leaders. So let's go to code blocks and let me demonstrate this for you to see. I'm just going to take you to where I created the extern example. So open. So I have the two files. I have extern example created, and I also have the extern demo. So the one I saved as main.c is this one. So I'm saving it as extern example.c. Then extern example, extern demo. All right. So this one contains the main function, while the second one only contains the definition of this uh, shared value and extern value. So let me add that one to this project before we execute, because as it is now, if you try to execute this one, it will tell you you cannot find it. So you see, it's giving you error. If you click here, it says undefined reference to extern example. So that is why. So I'm going to now add it by right-clicking this, and then add files. So I will come here and I will look at this extern demo. So this is it. So click OK. So when I click here, so I have it. So extern example and extern demo. So if you look at this, so this is it. Look at include stdio.h int shared value, assign 5 to it, then void extern example. Inside it, I have shared value increment. So I'm increasing this to what? 6. Then I'm going to print out shared value. Shared value will be what? 6. But that is not, I'm not calling it here. So the main is not defined in this place. So main is here in this second file. This is where main is. So extern example, I'm calling extern example here, and I'm calling it again the second time. So this is the one I'm going to run, and then you will see what the output will be. So now you see, so it's giving me 6 and 7 because the extern example, the shared value was originally initialized as 5. And then inside that extern example function, I'm incrementing it. So when I call it the first time, it increments it to what? 6, and then to print out the value. Then I'm calling it the second time, it will increment the value to 7, and then print it out. So that is what the value is. So you can see here, initially it's 5. When I increment it to what? 6, and then I call it in that file, then it will show me the output as what? 6 and 7. So that is what I want to show you in this class. So till we see in the next class. Bye-bye.